For this first section, I'd like to go into explaining a little bit more about the client-server model and talk a little bit more about servers themselves and how they're structured. Now, we're not going to really get hands-on with servers in this class. That's something we do more in advanced software or advanced web programming. It's also something you get deeper into if you're over in the IT side of things. But it is good to understand the basics, and I just want to sort of guide you through that part. First, starting out with this idea of the client-server model. The client-server model is essential to anything that you do on any sort of network or the internet or the web. In our case, client-server model is always going to refer to two very specific things. There are two computers involved in every transaction that happens on the web. The first one is the one you're sitting at, the one that you're using, your laptop, your phone, your desktop computer that is actually viewing the web pages, and that's called the client. More specifically, not everything inside that computer is involved in the web transaction. The thing that's most directly involved is the web browser. So whenever I talk about the client, I'm usually talking about the browser you're in. Google Chrome, Firefox, Microsoft Edge, Safari, whatever particular browser you're using, that in itself is really the client. It will execute the code that it receives from the server, which usually just involves rendering a web page. It will communicate with the server, and everything that happens inside that browser is sort of kept inside what we would call a sandbox. The sandbox is a safe place where things can execute that won't mess up everything else that's on your computer. Today, as I talk through this stuff, I'm going to have some Wikipedia pages pulled up. As long as you've already done the reading for the class and already gone through that sort of history of the web video, all of this should make quite a bit of sense. Some of it will be a little bit weird, but it's very good stuff to read through. Here I'm just looking at the client-server model page. If you'd like to know a little bit more about that in a little more generic of a way, this is a great place to go. Let's talk a little bit about the actual communication that happens between clients and server. So, as I mentioned, there's two computers involved. The other computer is out there somewhere else and has to be reached through a network. And that network could be very complicated, like the web, or it could just be a single connection away, such as if you're talking to your TV in your house. It never really has to leave your house. It just travels through the air, into the wires, over to your TV. But any sort of computer that's connected via the network can behave as the server. When you start to think about it, exactly which one's the client and which one's the server can start to get a little bit fuzzy. It isn't always clear cut. Sometimes what you're working on actually behaves like a server, even though you don't know it. For our purposes, we're going to keep that simple. The computer you're at that's viewing the web is the client, and the other computer that's involved will always be the server, and it will usually be sending you pages. Now, on the back end, exactly what that looks like is something like this. This is a very simplified example of how the client and the server communicate. We talk about communication across a network in terms of layers. There are many different layers that set up all the different sort of protocols or languages that the different technologies can speak. And probably the most important one in all of this, the one that we're going to have to deal with the most directly, is the HTTP protocol. No, really, it's just HTTP, Hypertext Transfer Protocol. It always works in this simple way. A client, aka your browser, sends a request to the server, and it is specifically an HTTP request. That request can take a lot of forms. It will always have within it a server name, which is usually the URL, it's up at the top, a method that it wants to use, get, post, put, something like that. Get being the most common, which means it wants to get something. And then it will often have a header with more detailed information, where you are so they can get it back to you, and information about how to get to you, various things like that. All that gets sent to the server. The server examines the request, and then it sends a response. And that response actually looks really similar to the request. The really only thing that makes it a response is the fact that it's coming from the server. It will have within it some information that says either no, I don't know how to process that, which is an error, or maybe I can't find that. You've often seen those. They're called 404 responses. Whenever you get a 404 page, it means you asked for something the server didn't have, and it says, I don't know where that is. And there's many other ways it can respond, but it responds with one of those codes. The most typical one would be 200. That means OK. And then it starts listing all the information you asked for, usually a web page. And then the client can start rendering that web page. Now, of course, this is a gross simplification, but requests and responses are probably the most important objects that you have to deal with when you're dealing with any kind of web page rendering or programming. Let's take a look at a little more detailed example of this. Here we'll expose some more layers that are available in here. HTTP, the Hypertext Transfer Protocol, really runs inside of something called TCP/IP. If you've ever looked at a whole bunch of numbers to describe a server, you're looking at its IP address. IP stands for Internet Protocol. Now, these are two-way connections, and they basically surround everything that you have to do. And you notice here the very first thing it does, this is, over time, top to bottom, it does a TCP/IP connect. And this is where the two computers say, okay, let's start talking. Then, here you'll notice it's sending a GET for index.html. This is an HTTP request. It says, I want to get the information inside of index.html. The server receives that, and it needs to immediately respond with a header that includes a code that says OK or no, or some other sort of information that says here's what I can do. In this case, we'll assume it says OK, which would be a code 200. It will then follow up with the actual response to the request. In this case, I said get index.html. Okay, here comes index.html. So very often there's a header first that includes that response code and some other information about what it's about to send you, and then it sends you the actual web page itself. From there, the client can do whatever it wants with it. Most of the time it will render it or execute it if it's code. Once it's all done, the TCP/IP connection is closed. Now, once again, this is a big simplification. There's way more going on in here than even this, but we don't need to go any further. If you're interested in more of this, there's plenty of extra information out there. Now, that gives you the basic idea of communication that's going to be happening here as we exchange information between a server and a client. Let's talk a little bit more about the server itself. In our class, we'll initially be having it such that the computer that you're on will be both the client and the server. The client, like I said, is everything that happens in the web browser. The server will be usually just a file sitting out there. The web browser will just go grab that file right off the desktop or off of your drive and render it. We can keep it that simple at the beginning. Eventually, though, we will actually start running a server on our local computer, and that server will be able to communicate with the web browser in a more intelligent way and actually receive requests and respond to them. Now it'll be running separately in its own little program. So let's talk a little bit about what those programs are and what the typical structure of a server is. A server itself really just needs to be a program running that is able to respond to requests. And usually specifically we're talking about HTTP requests. The most common form of that is something called a LAMP server. So here I am back again at one of these Wikipedia pages. LAMP is talked about in your book as well, so hopefully you read through that a little bit. The basic components of a server usually are just several different little programs that have to run to deal with all the things that are going to come in. So the first part of this is usually the operating system of the entire server itself. Let's go down here and look at the actual components. In LAMP, the L stands for Linux, and that is the operating system. That is the basis for a LAMP server. Not surprisingly, there are also WAMP with a W servers, where the W stands for Windows. Everything else about the two of those is the same. So that becomes the base that everything runs on top of. In addition to that, there will also be some sort of program that speaks the HTTP language, that protocol, so that when it receives a request, it knows how to interpret it and respond to it. And the A in LAMP stands for that, Apache. Apache has been around for a very long time. It is an open source, free HTTP server that can do all the basics that you need it to do and then some. It is old, it is somewhat bloated and slow, but in popular opinion, but it is also very robust, well maintained, and has a lot of large companies investing in it. It's also open source and runs on just about everything. So Apache is sort of the tried and true one. There are many others out there. There's one called Nginx. There's ones that you can sort of roll your own that are based on Node.js and something called Express. You have lots of options there once you start branching out. We're not really going to get into that in this class. That's stuff for advanced web programming. We will almost always be using some sort of a LAMP type setup. The next thing that you have is some sort of database. Now, this isn't required to actually run a server, but it's expected. Almost all web programs need to store and retrieve data in a secure and efficient manner. The M in LAMP stands for MySQL, or sometimes a few of the other alternatives out there, such as Mariah database, Mongo database, though very rarely, because Mongo is something very different. But MySQL is very common, and that's usually what the M stands for. MySQL is a database. It is a relational database that executes SQL, or the standard query language, and it's something you can learn a lot more about in database class. We will get into it just a little bit at the very end of this course in Unit 3. Again, some alternatives there. There is something called PostgreSQL, or Postgres, sometimes people call it. That is exactly like MySQL, and in that it's a relational database that speaks the SQL, or that speaks the standard query language. It's often considered to be more robust than MySQL, but it doesn't have as long of a history. So it is often not as it's not the first choice just because it hasn't been around as long. Kind of like Apache is mainly used because it's been around a long time and is trusted. Same for MySQL. The P usually stands for PHP, though it can also commonly stand for Perl or Python. So the P in LAMP is a scripting or programming language that runs on the server. We will be learning plenty about that in Unit 3 when we get into server-side technologies and server-side scripting. So keep in mind, just about any server that you want to provide needs to provide those basic things: an operating system that ties it all together, a server program that speaks the HTTP protocol, a database such as MySQL, and a scripting language such as PHP. Once we get into Unit 3, we will be running one of those locally on our computer. It will ultimately be something that provides PHP and can interact with MySQL, but will not be actually running MySQL itself. We'll get more into all of that as the time comes. Now, these days, LAMP has gotten to be very old. As I mentioned before, people consider Apache to be a very slow, though reliable web server. MySQL is considered to be clunky and large, and PHP is considered to be a bit of an old language that people don't like to use anymore. And consequently, a lot of new, slick alternatives have come in just the last 5 or so years that are starting to gain popularity. The vast majority of the websites you access nowadays, including Google, Facebook, and Twitter, do not run on LAMP technologies. They usually run on something called Mean instead. A Mean server is really a modern alternative to LAMP. And just like before, each of the letters in the server name stand for different things. First of all, they don't really call out a specific operating system that Mean needs to run on. It can run on anything you want, though it does still very often run on Linux. Instead, what they call out is first the database. The M in Mean usually stands for MongoDB. Very often an alternative to that is something called CouchDB. Both are used fairly interchangeably. The E stands for the same thing as Apache. So the web server, the HTTP server from LAMP, is replaced with the E in Mean, which stands for Express.js. This is a web application framework. The A in Mean stands for a special library that is used for creating front-end web pages called Angular. Usually Angular.js. There's 2 forms of Angular, Angular.js and then the newer Angular. And this is a Google technology that was created that is used to run most of the Google apps you know and love. It's just a library, and there's nothing equivalent to it really from LAMP in the name. It sort of takes the place of the L that is Linux. Linux is kind of implied in a Mean stack, or it really doesn't matter what you're running it on. The last thing is Node.js. Node.js is kind of like the operating system. It's a little, it basically is the JavaScript engine of Chrome pulled out, put on its own so that it can run without a web browser. And so that everything you do on the server side runs in the Node engine, where Node runs JavaScript. So it means that the server runs JavaScript everywhere. Angular.js, the .js means it's JavaScript. Express.js, the .js means it's JavaScript. MongoDB also speaks the JavaScript language. So mean is often called a full JavaScript stack, meaning that everything runs in JavaScript. You'll notice when I talked about LAMP, we were talking about other languages like PHP and SQL, in addition to the HTTP protocol and JavaScript that will run in the browser. There's lots of different languages working here. This is what we would call a polyglot programming environment, meaning many languages. The mean stack uses JavaScript everywhere. There will still be HTML and CSS, but as far as programming languages, it's all JavaScript. And this just helps your head hurt a little less. We will not be doing any mean in this class, but it is a big part of the Advanced Web Programming course. So if you want to know more about it, you can consider taking that course in the spring. With all that in mind, that'll be it for talking about client-server and server-side structures.